This lesson is for FST Lesson 1-6 on two new measures of spread, variance and standard deviation. Students have heard of measures of center before. We studied them previously in this chapter. They are the mean, the median, and the mode. Those should all be review items for students, not only from this chapter but from previous math years. The median is the middle number, and there is no special symbol for the median. The mode is the one that appears the most often, keeping in mind that sometimes there is no mode. And the mean is the same thing as the average. There are some symbols here that I want to mention about the mean. The one that we're going to use today is X with a bar over it. Students see that indicates that they are asked to find or calculate the mean. In the future, we'll also use a symbol called mu to indicate the mean, and it's kind of a script-looking letter M. We're not going to cover that today, but I thought I would mention it since it is a future topic. Measures of spread are other things that we use to describe data. So the measures of center are ways that we can describe how a data is centered, where the middle is. And sometimes we want to know or talk about how spread out the data is, and so we use measures of spread for that. Students have used measures of spread before as well, and students have been asked to find the range of a set of numbers that is a measurement of spread. In this chapter, we learned a new item called IQR, or interquartile range. Students can look back to previous lessons if they need a review of that. Two new items for today are the variance and the standard deviation. The standard deviation is the main one that we're going to talk about, so I'm going to de-emphasize the variance. When you're calculating standard deviation, you will be doing the variance automatically, so we're going to focus mostly on standard deviation today. The symbol for standard deviation is the lowercase sigma. It's kind of a funny shaped O-looking symbol with a hat or a brim on it. Sometimes they just use a lowercase s. Variance uses the same symbols, only it is squared. So if you see s squared or lowercase sigma squared, they mean for you to calculate the variance. On the calculator, when you're asked to do the standard deviation, which I will show students at a later date, the standard deviation is indicated by the letter S with a subscript X next to it. To illustrate standard deviation for today, we're going to use two sets of data, and these pieces of data come out of the textbook from page 45. They are simply two basketball teams, and they are dot plots of the players' heights of the two teams in inches. And so it's pretty clear that in the game of basketball, most people are in awareness of the fact that height gives you an advantage. As you look at these two teams and how the dot plots are spread out and how they are laid out or displayed, it's fairly easy to see that the Dolphin team has heights that are more spread out compared to the green Pepper team. Clearly, the Pepper team has more averagely heighted people, whereas the Dolphin team has all kinds of varying heights. So if we were to use that as a comparison between the two teams, we would simply say that the Dolphin team has heights that are more spread out compared to the Peppers. We wouldn't need any further information to make that decision. It's very clear from the dot plots. However, today, when you're working with large numbers of data, you may not be able to make that decision just by looking. So we're going to use a standard deviation calculation to make that same discovery. Before we do that, let's just talk about a couple measures of one measure of center and one measure of spread to compare the two. If you were to calculate the mean, you would simply take all the data here and add them up and divide by 10. Same thing here, you'd add them up and divide by 10. It's very clear on this one to see that if you added up everybody, because it is symmetrical, the average is clearly 75. When you calculate for the red or for the Dolphin team, you'll see that their average is also 75. So for that measure of center, it indicates that they have both teams are averagely heighted, but because they're the same, it doesn't really give us much information. When you calculate the range for both teams, you see the exact same result. Both have the same measure of spread of the range being 10. So it's oftentimes helpful to calculate other measures of center or spread to help you compare the two pieces of data or the two sets of data. So what I'm going to have students do next is go ahead and calculate the variance and the standard deviation of the heights of each team. I'm going to have the video explain how to do the dolphin team step by step, and then the students are going to complete the pepper team on their own, and then they can use the video to check their work. So basically all I did here was I took the dolphin team heights from the dot plot and I listed them vertically. And I'm going to call those my data, or x sub I. Before we go ahead and start calculating the rest of the information here, I'm going to show students the steps involved for making standard deviation, or for calculating standard deviation. The first thing you should do is calculate the mean. And so on this question, we've already done that. And so let's just write that down. For the dolphins, we know that the mean was 75. And so let's continue to mark here the symbols as we go. So calculate the mean, or calculate x with a bar over it. Next step is to calculate what's called the deviation. And to calculate the deviation, I have a little hint here on how to do it. You subtract the mean from each value in the table. Or another way to say it is take the data minus the mean. So we're going to do that in symbols as well. Remember that the data was x sub I, and we're going to take away the mean from each piece. So it's x sub I minus x bar. So let's go ahead and do that now for the dolphin team. Keep in mind here that you're doing data minus mean. So there may be some indicators here that you will get a negative number. So for the first piece of data, it's 70 minus 75, it's going to be negative 5. And then you do that for each piece of data. 71 minus 75 is negative 4. You get the same answer there. 73 is going to be a negative 2. And now we're going to get a 0, and then we're going to move into the positive numbers. So we've just completed the deviation step, or step number 2. Moving on to step number 3, you can kind of see what's going to happen next. We take those answers and we square them. Keep in mind that when you square them, you're going to get positive results each time. Negative 5 times itself is positive 25. And I purposely have some nice easy numbers for students to work with here so that you wouldn't technically need a calculator to complete that step. So let's go ahead and fill in the symbols. Notice how we would need to put in parentheses here because we want the square to occur after the subtraction. Step 4 asks students to do the sum of those numbers. Remember that the symbol that we use for that in this class is the sigma symbol. So I'm going to put sigma of x sub I minus x bar squared from 1 to n. And n is going to represent how many numbers we have, or how many pieces of data. So for this step, you're literally going to need to grab your calculator and simply add up all these numbers by typing them in. Unfortunately, there is no shortcut for that. In this case, we'll get 128. That is only half of step 4, so you still need to complete step 4 by dividing by the sum, or excuse me, divide the sum by n minus 1. Remember that n is the number of values that you are currently working with. I'll explain, if I have time, at the end of the video what the n minus 1 stands for. So we're going to take all of that after we've added it, and we're going to divide by n minus 1. So on our data, we are working with 10 numbers, or 10 players, so we will divide by 9. When you divide by the n minus 1, in this case, we get 14.2 repeating. That value is called the variance. Again, I'm going to diminish the value of learning that particular number. The piece that I care about that students learn is the standard deviation. And the standard deviation is done in the next step. You just take the square root of the variance. So we're simply going to do the square root of 14.2 repeating. And when you round that off, you get about 3.8. Now that number right now is fairly meaningless. We need it to be compared to the next set of data in order to make any decisions or draw any conclusions. So let's go ahead and finish off the steps here. The last step is step 5, to square root the variance. So you just take a big square root symbol and put that right in front. So that is the symbolic way of showing or saying, take the standard deviation. So students can now go through and do the other team and do all 5 steps. I'll go ahead and have the students pause the video right now, and then I'll quickly fill in the values for them. So now you can see that I filled in all the numbers. You see that I saved the easier team for the students to try on their own. The sum in step 3 should be 52. Divide by 1 less than the number of pieces of data, which is still 9, and you get the variance of 5.7 repeating. Square root that to get the standard deviation, and you get 2.4. Now that we have two standard deviations to compare, the standard deviation that is the larger of the two represents the data that is more spread out. We already knew that that was true of the dolphin team. We already knew from the dot plot that their heights were more spread out, but now we have the mathematical data and the standard deviation to back up our claim. We don't know how much bigger it is. We just know that it's got a bigger standard deviation, so it is more spread out. So let's go ahead and summarize now. The heights of the dolphin team differ or are more spread out from those of the peppers. Mathematically, the variance in the standard deviation for the dolphins will be greater compared to the peppers. That is because generally data that is close to the mean will have a lower standard deviation compared to data that is further spread out from the mean. In picture form, I've got three little histograms here. Notice that the means of all three are identical. If you compare the S, the standard deviation, the one that has the highest standard deviation is the one that has data that is the most spread out. So all you could conclude here is that the data that's the most spread out is the purple one or the one on the far right. The last thing I want students to take a look at is how standard deviation in symbol form looks in the book. In the book, they give it to you in this big yellow box, and they give it to you with all these scary looking symbols. They also give you two. They give you one for population, and they give you one for sample. Rather than making students memorize both, I've decided to have students just memorize the one for the sample that involves dividing by n-1. I believe that using the standard deviation of a sample, you divide by n-1 because we assume that one of the pieces of the sample is an outlier. So it's almost like throwing out one of the pieces of data. So rather than memorizing both formulas, students simply need to do the standard deviation of a sample. So in conclusion, I just want to leave the student with the 5 steps. Calculate the mean, calculate the deviation, square each answer, sum them, divide by n-1, and take the square root. Students will be responsible for knowing how to do that by the time they reach their next quiz or test from chapter 1. And so students need to get comfortable practicing that over and over.